Solving radical equations. When we solve radical equations, the very first step we want to do is we need to isolate the radical. So get the radical by itself. So in order to do that, what I want to do is I need to move this plus 3 to the other side of the equation. So in order to move 3 to the other side of the equation, I'm going to minus 3 from both sides. And I'm left with root 2x plus 1 is equal to 7 minus 3 would be 4. Now that my radical is isolated, we need to remove the radical. By squaring both sides. So I'm going to square both sides. So when I do that, this squared basically just cancels out that radical, and this is left with just 2x plus 1. I'm also going to square the 4, which gives me 16. Now what I'm left with is just a linear equation to solve for x. So I'm going to subtract 1 from both sides. And then I'm going to divide both sides by 2. Okay. So that third step, you're just simply solving the equation that you're left with. Okay. And then lastly, with all radical equations, it's really, really important that you check your solution in some form. Either by graphing both sides and getting your x-intercept, or by substituting in your x value back into your equation. So you always, always, always need to do a check. So I'm going to take the square root of 2 times 7.5 plus 1 plus 3 should all equate to 7. 2 times 7.5 is 15. 15 plus 1 is 16. Square root of 16 is 4. 4 plus 7 is 7. So this does check out. So after you've checked your solution, you can go back and box your solution off. The reason why we check for solutions is because what can happen is if your check does not check out, where your left side does not equal your right side, what happens is the solution you solve for up here ends up to be what is called an extraneous root. And an extraneous root is a solution found but does not satisfy the equation. So you can solve for a solution, but it actually will not check out. And we'll do some examples of that.